Welcome everyone to this first training session in the scope of ARCADIAN IoT project. So, as you all know, today's session will focus the identity management aspects for IoT. I will just provide a brief overview of the project, some of the drivers, and the associated challenges to our project. So, one of the reasons we're all putting our energy into this, right, is the fact that IoT has become a crucial and important part of our society, right? With its penetration reaching most or all of the economic sectors, right? And this is seen by a huge number of deployments, both including services and devices, ranging a wide range, spanning a wide range of technologies. On the other hand, we see that, especially in the beginning, and it slightly improved nowadays, but we are still not there yet. IoT solutions come to the market with a wide range of vulnerabilities. Okay, with the main focus being deploying and delivering the service as soon as possible, and without putting much focus on security. A bit like the beginning of the IT world a couple of decades ago. And this has been and is being exploited actively by attackers, both with criminal purposes and in other segments. And and if we look at very recent numbers from the beginning of this year, based on a study from a well-known company acting in the cybersecurity field, we see that the number is only increased, right? The frequency of attacks, and equally, well, the number both of the attacks and the number of organizations affected are only increasing, and also very interestingly, European organizations are actually the most targeted according to these numbers. So even though there are challenges, okay, there are some well-known cybersecurity best practices for IoT. So the usage of unique credentials, leveraging secure private key storage, continuously and frequent firmware and software updating, and its verification. The well-specified and dependency on root of trust and a clear chain of trust for trustworthiness purposes, and also the monitoring of both keys and root of trust. Even though there are these not yet fully followed guidelines, the scope for the ARCADIAN and the main identified challenges include we don't see that security and privacy are managed together, so they are typically addressed in a fragmented way. We have a strong dependency or involvement of the human factor in both monitoring, forecasting, and updating, and among others, security operations. So it's highly prone to failure. We also see a well-dispersed threat intelligence communication sharing with the usage of different tools and different standards. So in the end, we don't have a single unified approach for sharing threat intelligence. The emergency of technologies such as AI and 5G only contribute to the increase in the attack surface, and as well as the risk of propagation of vulnerabilities and incidents. Very importantly, We also witness current solutions are mostly centralized and static, and in particular focusing trust management and recovery approaches. And we also witness lack of trustworthy methods, both for persons and objects or devices identity management. So this later one is particularly important to today's training sessions. So we will be going through some, sharing some knowledge and providing some hints for how IoT service providers uh, could leverage some of the Arcadian IoT solutions. So Arcadian IoT is, aiming to address this, is devising a framework for holistically addressing the different aspects associated to IoT security, namely those of trust, privacy, identity management, and recovery management. So, and to do this, it also adopts a mostly decentralized approach while having particular care with respect to privacy and transparency regarding the user control over privacy aspects. So this is the consortium. I won't go through in detail into here. Okay, we have defined 7 main objectives. So the first one being specifying and implementing this decentralized framework for supporting IoT systems. The second one, the most relevant for today, to have secure and trustworthy management of objects identification. Again, objects here being able to represent both devices and other types of IoT artifacts. The distributed security and trust in person identification management, equally important for today, as today's solutions cover both identification of persons and devices. The fourth objective being the distributed and autonomous models for trust, security, and privacy, enabling a chain of trust for IoT. So we will actually cover these aspects in a follow-up training. The fifth objective being supporting hardened encryption with recovery ability. The sixth being self and coordinated healing while reducing human intervention, both for devices and the network supporting the IoT services. And finally, to enable proactive information sharing for more trustable or more trustworthy cyber threat intelligence. So this sums up the main objectives of the project. I will now give a brief overview of how these objectives are translated into Arcadian framework. So it comprises 6 planes, 3 of them horizontal, 3 vertical ones. Each of the planes addresses a particular important security scope, or security related scope. The first being identity. So again, to emphasize, this is today's focus with respect to the training being provided. The other planes being trust management and recovery management. The 3 horizontal planes being addressing privacy, security, as well as delivering common components or models which may be leveraged by the other planes. So for instance, leveraging hardened encryption for the purpose of encrypting data and other information shared by devices with the support of a hardware-based root of trust such as eSIM. Well, I will also just provide a slight overview of the use cases or the application domains being addressed in the project. So we have three main domain areas. The first one being a service named Drone Guard Angel, where in a Uber style application, a user is able to invoke a drone to monitor its security from point A to point B. So there are many different challenges associated to this, starting with um, privacy and data protection, given the fact that we need to monitor the user, identify it. We are also collecting image from a public space, so we must ensure we are not identifying other users and so on, just to discuss a bit this, a couple of challenges in this particular case. With respect to the second application domain, we have a solution for monitoring grid infrastructures via the collection and aggregation of sensor data supported by a IoT gateway. So in this case, there are particular aspects associated obviously to the ensuring the confidentiality of the company data, right? It can be critical infrastructure, for instance. It can be uh, a public operator where it is of the most importance ensuring that this data is not visible to exterior entities. So yeah, in this part, it's also quite important the fact that we must be able to have a device leading with the constraints of IoT, such as energy and power consumption. So finally, the third domain in the medical IoT domain regards the remote monitoring and follow-up of cancer patients at home. So particularly intends to address this ability to not having patients having to go to the hospital for monitoring for following up its status. And in here again we have a significant challenges associated to the privacy preservation, to confidentiality of data, given the fact that we are dealing with health data. And again, in all of the domains, we are also addressing different incidents. So the framework, as we saw, has features for both detecting and addressing mitigating these incidents. So when I talk about incidents, I refer both to incidents targeting the devices or targeting the service itself. So thank you. So this, ARCADIAN IoT is a EU-funded project. So you might find any information you wish in this link. Okay, that's all.